This is Lesson 3-1, Graphing and Writing Inequalities. We're going to compare two numbers, graph an inequality on a number line, write an inequality for a graph, a statement, and a real-world problem. You do not have to write this information on your paper. You need to know that an inequality is a statement that two quantities are not equal. The quantities are compared by using the following signs: less than, greater than, less than or equal to, or greater than or equal to. A solution of an inequality is any value that makes the inequality true. You will need to learn these inequality symbols. We will not call them alligators, Pac-Man, or any other names you've called other than less than or greater than. To help you remember, less than makes an L like your left hand. Number 1, copy this to your paper. We're going to compare by writing less than, greater than, or equal to. We're going to compare -9 and -5. You should pick that -9 is less than -5. Be very careful with this one. You may think that 9 is greater than 5, which is true, but we have -9 and -5. This means because the numbers are opposite, we must think opposite. So -9 is less than -5. Example number 2. We have 0 and -11. When you compare, you should pick that 0 is greater than -11. Example number 3. We have 0.15 compared with 1/5. We will need to convert both numbers to the same form. So let's change the fraction to the decimal. 1/5 is the same as 0.2. So this means that 0.15 and 0.2, when we compare, 0.15 is going to be less than 0.2. Example number 4. We have 3/4 we're going to compare with 0.75. Again, convert to the decimal, and we see that these are equal. Example number 5. Try this one on your own. -20 compared to -14. We should pick that -20 is less than -14. Again, be careful when working with negatives. You got to think opposite because they are opposite numbers. So that concludes comparing two numbers. We're now going to graph an inequality on a number line. Copy number 6 to your paper. This is set notation for inequality. We will use this throughout this chapter to write our answers. You read this as the set of all x's such that x is greater than or equal to 5. So in order to graph this, we'll make a number line, do 2 less than the 5 and 2 greater than the 5. So make your number lines from 3 to 7. A line underneath the inequality symbol means equal to. You must fill in the circle to indicate that we want it to be equal to 5. A way to help you remember that is extra mark, make it dark. So we're going to have a dark filled in circle on the 5, and we want to shade neatly the number line that would show numbers greater than 5. So that means we're going to shade towards the 6 and the 7. You should also shade your arrow. This graph shows greater than or equal to 5. Example number 7. We have the set of all x's such that x is less than -0.8. Again, pick two numbers less than and two numbers greater than the -0.8. You can count however you would like as long as you're consistent in your counting. Here you can see I counted by tenths. So my number line goes from -1 to -0.6. Here we will have an open circle on the -0.8. No line under the inequality symbol means that the answer cannot equal that number. So an open circle, and we're going to shade towards the less than side. Neatly shade your number line and also shade the arrow. Example number 8. Go ahead and make a graph of your own. Remember, 2 numbers less than and 2 numbers greater than the 23 is what you should show on your number line. Let's check your answer. You should have made a number line from 21 to 25. Did you pick an open or closed circle on the 23? It should be a closed circle. We're going to shade towards the greater than side. Make sure you've shaded your arrow as well as the number line, because these numbers do continue greater than 23. Example number 9. Try this one on your own. Let's check your answer. When we make our number lines with negative values, always be very careful. You've got to think opposite because the numbers are opposite from positives. So when you make your numbers 2 less than and 2 greater than, be very careful thinking about where the 0 would be on the number line. So your number line should go from -4 to 0 with a closed circle on the -2. Remember, extra mark, make it dark. And we're going to shade towards the less than side. Notice each time that we shade, it's in the same direction that the arrow is pointing. This was the case on all of these examples 6 through 9. That will always be true if your variable is on the left of the inequality symbol. You may just look at the inequality symbol and shade in the direction the arrow is pointing. We're now going to write an inequality given a graph. Copy this graph to your paper. We are going to write our answers in set notation. First, look at the circle. If it's an open or closed circle, that will tell you if it needs to be equal to or not. Here we have a closed circle, so we will put an extra mark because it's dark. So write your set notation. It's the set of all x's such that x is going to be greater than or equal to. It's greater than because the shading is greater than -8. And we have the value -8 in our set notation. Example number 11. Copy this graph to your paper. Set up your set notation. It's the set of all x's such that the variable x, this time it will be less than but not equal to. That's an open circle, so we will not have it equal. -1.9 will be the value. So this is our answer, the set of all x's such that x is less than -1.9. Example number 12. Try this one on your own. Pause the video at this time. Let's check your answers. We have the set of all x's such that x, the symbol you should have chosen is just greater than, not equal to, because our circle is open. Our numbers are shaded on the greater than side of 13, and that's the value in your set notation. Number 13. Try this one on your own. Let's check your answers. We have the set of all x's such that x is less than or equal to, we will need the extra mark. 0 will be the numerical value. So this is our answer for number 13. The set of all x's such that x is less than or equal to 0. That concludes graphing an inequality on a number line and writing an inequality for a graph. Now let's write an inequality for a given statement. When we write equations, the word is means equals. We're writing inequalities, the word is will be followed by a phrase indicating an inequality symbol. Watch for this as we go throughout this lesson. Example number 14. Copy this to your paper. A number decreased by 3 is less than 26. We're going to translate this into an inequality statement. A number will represent a variable. Let's let it stand for n. Decreased by, we'll be subtracting. 3 is the number 3. Is less than. This will be an inequality symbol. Before, when we were writing equations, we talked about less than indicating subtraction. However, in this problem, is less than indicates the inequality symbol. Because of the word is, we know it's an inequality symbol. 26, we'll use the value 26. So write the inequality as your answer. We have n minus 3 is less than 26. Example number 15. Copy this to your paper. We have twice the number is more than the sum of that number and 14. Twice the number. Twice means 2 times, so we'll do 2 times a variable. Is more than. Notice the word is followed by the words more than is going to be an inequality symbol. Before, when we were solving equations, more than indicated addition. Now, because it says is more than, it's going to be an inequality symbol. The sum of that number, so plus that number, n, and 14. So our answer will be 2n greater than n plus 14. Example number 16. Copy this to your paper. We have 5 times the number increased by 9 is greater than 65. So 5 times the number. That'll be 5 times a variable. Increased by will be addition. Increased by 9 will have the number 9. Is greater than. Again, because of that word is, we know we're going to use an inequality symbol. Look for that word is. The word is indicates equal signs, but because we have the greater than following that, we know we use an inequality. Greater than 65. So 5n plus 9 is greater than 65. Example number 17. Copy this to your paper. We have 45% of a number is greater than or equal to 70. 45%. 45%, we will want to change it into a decimal when we write our answer. 45% of a number, we're going to multiply 45% times our number that we will use as a variable n. Is greater than or equal to. Don't forget your equals to part of your symbol. Greater than or equals to, it needs to have that extra mark. 70 will be the numerical value 70. So our answer is 0.45n greater than or equal to 70. You will not want to just have 45n greater than or equal to 70. Think about it. Do you want 45% of a homework or 45 homeworks? I bet you all said 45%. Example number 18. The sum of a number and 16 is at least 34. Start off with the sum, so we know I'll have addition, of a number. Use the variable n, and 16 is at least. Think about that. If I told you to get out at least 2 pieces of paper, you would need to get out 2 or more. So is at least is greater than or equal to. If I told you to get out at least 2 sheets of paper, you could get out 2 or more, greater than or equal to that many. Is at least is greater than or equal to. And then 34, use the value 34. So have n plus 16 is greater than or equal to 34 as our answer. Example number 19. We have 50 is no greater than twice the sum of a number and negative 12. 50 is the numerical value 50. Is no greater than. Be careful with this one. If 50 is no greater than, it must be less than or equal to. 50 is no greater than, so that's less than or equal to. Twice the sum. We talked about this when translating equations. Twice the sum, we need to show parentheses. 2 times parentheses the sum of a number and negative 12. So 50 is greater than or equal to 2 times the parentheses n plus negative 12. This answer would be incorrect without the parentheses. Also, because it tells us we want the sum of a number and negative 12, we will leave it as the sum of a number and negative 12. Do not simplify this and make it just n minus 12. Example number 20. The sum of a number and negative 1 is at most 14. The sum is addition of a number, so use a variable n, and negative 1 is at most. This is where you've got to be careful. Is the sum more than this? Is it less than this? Could it be equal? If the sum of a number and negative 1 is at most 14. The sum of a number is at most 14. It must be less than or equal to. Of course, 14, you'll use the numerical value 14. So n plus negative 1 is less than or equal to 14. This shows that the sum of a number and negative 1 is at most, is less than or equal to here, is at most 14. Number 21. We have 3 less than a number is no more than 10. So we have 3 less than. In this case, 3 less than is subtraction. Less than is those turnaround words where we put the 3 after the symbol that shows subtraction. If it said is less than, that would be an inequality symbol. A number, use the variable n, is no more than. So is it more than this? Is it less than this? Could it be equal to? If 3 less than a number is no more than 10, is it more than that? Could it be less than that? How about equal? If 3 less than a number is no more than 10, it must be less than or equal to. Of course, the numerical value 10 will finish our answer. So we have n minus 3 less than or equal to 10. This shows 3 less than a number is no more than 10. Use less than or equal to show is no more than. That concludes writing an inequality for a statement. We will now write an inequality for a real-world problem. Example 22. Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees Fahrenheit. Define a variable and write an inequality for the temperatures at which Ray can turn on the air conditioner. We're going to graph the solutions on a number line. So when we define a variable, we're going to choose T for temperatures at which Ray can turn on the air conditioner. We're now going to write an inequality. To turn on the AC when the temperature is at least 85 degrees Fahrenheit, turning on the AC is going to be our variable T. Is at least, think about this, is at least is greater than or equal to. If you could turn on the air conditioner, must be is at least 85 degrees. The temperature must be greater than or equal to 85. So our inequality in set notation is how we'll write our answers, is the set of all T's, or the set of all temperatures, such that the temperature, or the T, is greater than or equal to 85. The set of all T's such that T is greater than or equal to 85. Our final thing is to graph the solutions. Remember, you can go 2 less than and 2 greater than the numerical value you have. So I'm counting by 5s here. So 75, 80, 85, 90, 95. As long as you're consistent in your counting, you can be counting by any values you would like. Extra mark, make it dark, so we will include or make it equal to 85, and shade greater than 85 on our number line. To turn on the air conditioner, the temperature must be at least 85 degrees Fahrenheit. Our solution and graph shows us that as our answer. Example 23. A store's employees earn at least $9.50 per hour. Define a variable and write an inequality for the amount the employees may earn per hour. We're going to graph the solutions on a number line. So to first define a variable, we're going to let W be the employee's wages or earnings. When we write our inequality, we have an employee that earns at least $9.50 per hour. So the earnings part we said we will let be equal to W. At least. Be very careful to think about this. If the employee's earnings are at least $9.50 per hour, then that would be greater than or equal to $9.50. So our set notation is the set of all W's such that W is greater than or equal to $9.50. You could also say this as the set of all earnings or wages such that the wages are greater than or equal to $9.50. Our final thing is to graph it on a number line. I'm counting by 50 cents, so 8.50, 9, 9.50, 10, and 10.50. Again, be consistent in your counting when making your number lines. Extra mark, make it dark. We will include 9.50. And we're going to shade greater than $9.50. This shows an employee earns at least $9.50 per hour. That's greater than or equal to $9.50. So this concludes writing inequality for real-world problems.